Okay, so today's tutorial is on the ideal gas law. The ideal gas law is a hypothetical law which approximates the behaviour of most gases under a variety of different conditions. Some students who've done physics before would have met Boyle's law or Charles' law, and the ideal gas law is a combination of both of these two laws. Now we can represent the ideal gas law by using the formula PV equals nR capital T. Okay, where P represents the pressure, and the pressure is in the unit pascals. V represents the volume, and that's in meters cubed. N is the number of moles in the unit mole. R is the gas constant, or the ideal gas constant, and has a value of 8.31 joules per Kelvin per mole. Okay, and finally we have T, which is the temperature, and the temperature we don't measure in degrees Celsius, but instead we measure this in Kelvin. Okay, so we're going to use the Kelvin scale to do these questions. Now, in a typical examination question, you will be asked to calculate one of these 5 different variables. Okay, so to show you this in a bit more detail, I've got a examination paper lined up. Okay, so this question 5A from the Chem 1 January 2013 paper. Okay, and it really is an important question to be able to do correctly, because as you can see, if I scroll down a little bit further, it's worth 4 marks. Okay, so what's the actual question asking me? It says 5A, in one production run, the gases formed in reaction 1 occupied a total volume of 4.31 meters cubed at 25 degrees Celsius and 100 kilopascals. And if I quickly go back again, it says the total volume, okay, of reaction 1. Okay, it's asking you to calculate the amount in moles of NO produced, and finally, give the answer to 3 significant figures. Okay, so there's a lot of things we need to do, and I'm going to quickly show you what you shouldn't do, and then think about where the students have gone wrong, and then go through the correct technique. Okay, so first of all, the incorrect technique. What some students often do is they rush into the question. So just to show you that it's not the correct technique, I'll put a cross here, definitely don't do this in the exam. Now what they do is they write down very, very quickly, okay, I know this question, it's ideal gas, PV equals nRT, and they simply rearrange the formula to get N equals, take these 2 terms down, equals PV over RT. Okay, so far so good. But then they use the values given to them in the question directly without any change of unit. Okay, so let me give you an example. Something I've seen before is that some students do the following. They, instead of looking at the pressure being a kilopascal, they just put the value in as 100. Okay, so they put 100. They put the volume, as 4.31. Okay, and then finally they do that all over R, which is 8.31, they assume, and then times by temperature, which is 25 degrees Celsius. Okay, and this is most definitely, most categorically, the wrong way to do it. Okay, so what is it in this question that makes this wrong, this method that we've actually chosen? Well, the first thing we should have done, really, is we should have converted our kilopascals into pascals. Okay, so we shouldn't really use the number 100. We should really be using for pressure 100, kilo being 1,000, 100,000 pascals. Okay, 4.31 as the volume is actually correct. 8.31 is the correct term as well for the gas constant. And finally, the temperature is incorrect. This is given to us at the minute in degrees Celsius, so we need to convert that value to 25. We're not going to use. So really, the temperature equals 25, and then we're going to add 273 degrees Celsius, because that is how we convert from degrees Celsius to Kelvin. And we're going to get, so we add that to 273, and we end up with a value of 298 Kelvin. Okay, so here are our new terms. Okay, so we've got a pressure term and then a new temperature term. Okay, the actual use of this method here of rearranging the formula is correct. So we'll go back to this slightly more further derived equation and put the numbers in now. So this is the correct method. So N equals PV over RT. Well, the new pressure we're going to use, if we quickly scroll up, is 100,000 pascals. So we're going to use 100,000. And then we're now going to use a volume. The volume was correct as before. So we're going to times that by 4.31. And all that is now divided by gas constant 8.31 multiplied by the temperature in Kelvin, which was here 298 Kelvin. So there it is. There's our equation. Okay, so next thing I need to do is get my calculator out. Here it is. So what's our equation? Well, we've got 100,000 times by 4.31, and that's divided by, use our brackets, 8.31 multiplied by 298. Okay, close that brackets. We get a value of 170.044 blah, 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 blah. Okay, so we only really need to write down the first couple of significant figures. So we're going to write down the value as 174.0, and the unit for moles is mole. Okay, and here's another thing that some students do. They think that's the end of the question, life's good. But it's not quite, because this is what we've just worked out, is the total number of moles. Okay, so the total mole. Okay, how do I know that? Well, in the question, it did tell us that the total volume was 4.31. Okay, so how much of that total volume is due to the nitrogen monoxide, due to the NO? Well, in terms of moles, I have 4 moles of NO and 6 moles of water gas. Okay, so in total we have 10 moles, and the NO, that is only 4/10 of that number. So really, the number of moles of NO equals 174.0 times by 4/10. Okay, so let's put that back into our calculator. Up it comes, times by 0.4, and my final answer, as you can see, is 69.6. So 69.6 mole. 2, 3 significant figures. And it's very, very important you write down the number of significant figures that you have. Okay? So where are the answers? Where are the marks in this question? Well, the first mark, I'm fairly confident, is due to this conversion of my pascals from kilopascals. So I'm going to put here 1 mark. The second mark, I'm fairly confident, is the conversion of degrees Celsius into Kelvin. 2nd mark. Okay. The third mark would be for working out the total number of moles, 1 mark. And the final mark is for working out the number of moles of NO. So here's our final mark. So 4 marks, 4 different points that you must write down to get the full final answer.